All right, hi guys. Today we're going to be talking about computer-aided design. So to do this, I'm going to use the platform Onshape. So just a quick comment about Onshape. So Onshape is free to all students as long as you provide proof that you are a student. They will give you a free educational license, and you can just use the software. It's not as good as professional, but it certainly works very well in terms of a CAD software. Um, so why are we learning about computer-aided design? By using computer-aided design, it allows you to iterate through your designs much quicker, and it allows you to find different issues with your design before you actually build it in real life. So this allows you to iterate quicker and it allows you to create less waste, both in time and material, especially if you're going to be investing in custom parts. So, um, so the basic concepts of Onshape are basically to how to import a part and how to create a document. Part importing is basically how you get pre-made parts into your document so you can use them, and document creation is basically how you get your assembly files and your part files. So basically, part files are where you create the custom parts that you want, and assembly files are where you put them together. So let's dive into the first key concept. So, so first, we're going to talk about part creation. So Onshape works on the platform that basically you first create a 2D face, and then their program helps you translate that 2D face into a 3D face. So what am I talking about? Let's go over here. So I'll quickly go through a quick process. So you can see, if I first go under here and I create a new part studio, so first I'm going to select a plane. So let's just say I want to sketch on the top plane. So now that I've selected a face, what I'm going to do is I'm going to draw whatever shape I want. So in this case, I'm going to draw a random rectangle. So you can see over here, I draw a rectangle. And so I click the check mark, and then basically here on the top bar, if you see on the where my cursor is hovering, this is the function that allows you to convert this 2D face into basically a 3D part. So if I go ahead and click it, and you can see if I just click on this face, you can see what it does is adds depth to whatever you just created. And so if you look over here, now we have like a rectangular pyramid. So now let's continue. So after this step where you turn the 2D surface into a 3D part, we're going to fix and make edits. So why I wrote in step one, not just select plane, but select face, is because you can actually create sketches on top of parts and keep editing them until you create the part you want. And there's also other features where you can cut your part and kind of curve it into the shape that you want. And these functions I will talk about later. So first, let's talk about sketching. So sketching is the first step, which is after you selected your face, we're going to draw your 2D plane. So you can see over here, Onshape gives you a variety of different tools that you can use to create this 2D sketch. And in order to use these function successfully, you need to know that there are three different ways that you can define a single shape: by its center, by two corners, or by matching it to an existing thing. So that is going to be your aligned function. You can see for rectangle, you have corner rectangle and center point rectangle, and aligned rectangle, circle, so on and so forth. So let me show that in action for you. So let's go back to the sketch I created. So over here, you can see, let me delete this first. So here's the first function for, let's just use rectangle as an example. So this is the two corner rectangle. So first click, I define one corner, and then I drag to basically create how high and how wide it is. So this is going to be corner define. So corner define, you usually use this as an add-on because, or like when like an edge is defined, because it's like really fluid. Like I'll show you the next function. You'll understand why this is not like the most commonly used one. So if I delete this over here, you have the center rectangle. I like to use this to start off every part creation because it helps me define the part to a certain location on the map. So over here, you can see my origin. If I set this as my center, I can drag out a rectangle and it's going to be symmetrical both in the X and Y axes because what you first define is the center, and then you're just defining another vertice on the rectangle to draw it out. So over here, you can see I created a rectangle and what's defined is the center point and another point. And then, so it's the same with circles. Circles, you're most likely going to be using a center point. So basically, once again, you click, first click, you define the center. Second click, you define one vertice on the circle, and that defines the circle. And I could do that for every other one, but I'm going to move on to this other feature called polygons. So sometimes, or like sometimes you can't really draw like a perfect polygon by hand. So like you can use a bunch of definitions to get a polygon, but that's going to take a lot more time than this tool. So this tool, it allows you to either inscribe the polygon, which is draw the polygon outside of the circle, or circumscribe the polygon, which is draw the polygon inside the circle. So if that didn't make sense to you, let me demonstrate that for you. So first, once again, first click, since you first have to define the circle, first click is going to be defining the center of the polygon. And so once again, I'm going to define this at the origin. So you can see as I drag it out, you can see the circle is inside the polygon. And this is always going to be a regular polygon. And if you don't know what that means, it means a polygon with all sides equal and all angles equal. So once I click, this defines the inside of the circle. And now you can begin the next part of the process, which is selecting how many faces there are. So as I move my mouse, you can see that it's going from 3 sides to 4 sides to 5 sides to 6 sides, and it can go all the way up to infinity. So this is really helpful when you want to quickly draw a regular shape and you don't want to draw one line at a time. And it also helps you define this to a certain point, as you will see later on. And then the last one is font. So basically you can drag out a text box and you can type whatever you want in this text box. And then once you click check, basically it displays your text on there. So you can see over here. And then this is different from, so this one, to edit the text, you have to right click on the text and then you can click edit text and then you can just edit the text. There's also different styling options that you can use, but this is really only used once you're done with creating your robot and you're just adding decorations. So I won't be going into this function into detail. So now I'm going to teach you about the next step. So the next step is basically 2D to 3D. So basically there are two options that you will most commonly use going into FIRST robotics, which is basically extruding and revolutes. So what's the difference? So extruding, which is the function I first demonstrated, is displayed on the bottom right corner, as you can see. So what this does is it just adds depth to the plane that you sketched. However, revoluting is different because it takes an axis that you selected and it sweeps the plane that you drew around that axis. So let me go ahead and demonstrate that. So once again, I'm going to head back to my sketch and I'm going to first draw a rectangle. So let's say something like this, and I'm going to use the revolute and the extrude. So first, I'm going to use extrude up here. So it's right next to sketch. So you click it and you can see it just adds depth to your plane, right? And then if I click OK, you can see this is a rectangular prism. And then if I use a revolute mate, you can see it asked me to select a face, just like the extrude, but this time it also asks for revolve axes. So you can see I'm going to select 2 different revolve axes for you so you can see how revolve axes changes the geometry. So first I'm going to go on the long side and you can see we have a longer cylinder. So basically, let me do this real quick. So basically you can see what it did was it swept the rectangle around the axis I selected, which was this axis right here. And then I'm going to select the next axis now. So you can see I'm going to change it to horizontal axis. And you can see, once again, it sweeps that face around the new axis to create a circular object. So now you might be wondering, why would I use this function instead of using extrude? Aren't they kind of the same? Well, my answer is no, because what Revolut allows you to do is it allows you to create complex geometries that are circular that you can't otherwise do with an extrude. So right now you can see, like, if I drew this circular face and I used an extrude, you could create the same cylinder. But if I go in here and I just edit the sketch a little bit, so let's say I add some random lines in the middle. So now when I run the Revolut on it, let me select the right face first. So now when I run the Revolut on it, you can see that it creates a shape like this. So a shape like this is impossible to extrude because there's like no way you can convert this flat plane into something like that. So what Revolut allows you to do is it allows you to basically create a cross section of any cylindrical object you want and sweep it around to how many degrees you want. Question?
Is there like a unit? Like what units?
That's a really great question. So, what I have right now is I have all my units defined in centimeters. But if you go up here on the three bars right here, you can actually change your units. So if you go down here, you can see you have workspace units and you can select centimeters. You can select acceleration and then how you want to display your angles. So this is important. When you start creating your own parts, but not so much when you're making your part, or not so much when you're just assembling like pre-made parts together. Because when you go to print this out, it's going to the manufacturer is going to ask you like what units are you using so they can accurately like make what you designed. Do we have a question? That's a great question. So yes, we actually this software is what enables you to do 3D printing because this gives the 3D printer an idea of what to print. So the process looks something like this. So after I made my object, what I do is basically I export it and then this exports it into basically a 3D object that is readable by another software. Um, so this software is called a slicer. So what it does, it reads in like your software, and the slicer itself has another software to decode that and turn that into paths for the 3D printer to follow, and that creates like a G code file. And then what you do is you save the G code file onto a SIM card, and then you insert it into the printer, and the printer will read the G code file from the chip, and it will tell you basically it will tell your printer in what ways to move the nozzle in order to create the part you want. Do we have any more questions? All right. So now we're going to go into the next step, which is polishing. So now that we've created a part like this, let's say I wanted to kind of round out the edges. So let me talk about the different ways you can polish. So first is the fillet. So what fillet does is basically it takes an edge. So it's basically taking two intersecting lines and it's just rounding it out by drawing a curve onto it. So you can see over here, you define what radius you want the curve to be. So as you can see, as I increase the radius, the filleted edge is, or like the fillet is greater. So you can see this is more rounded out. And then as I decrease it, you can see the corners coming back together. Does that make sense? And then chamfer does something similar, except it kind of just connects 2 points on the line together. So let me just demonstrate that for you. I'm going to do this on a flat edge so it's more apparent. So if I go like this, and then I decrease it to small. So you can see what it does is it basically, what it did was basically it connected this line, which is 0.5 centimeters from the point you selected, and this line, which is 0.5 centimeters from where you selected. And it just creates a line and it reconstructs it with this profile. So what these allow you to do is it both allows you to round out your part so that it looks better, but also it allows you to add on. So if I had, so let me edit this sketch real quick. So let me, if I change this on into like a rectangular thing. So if I delete this right here and created like a crevice inside, and then I ran the Revolute again, you can see right now these are like 90 degrees, right? But if I use either chamfer or fillet, so if you look over here, if I use a fillet, what it does, it kind of adds the support to the 90 degrees. So that way, especially if you want to 3D print your part, this gives it the strength and it helps your parts not break when you're actually using it in the real world. And so before we go into assemblies, I'm going to teach you how to actually make a part. So the part in question will be a pulley that looks like this. So we're going to use the pulley later in this assembly. So looking at its circular nature, can anyone guess how we're going to translate a 2D shape into the 3D shape to create this part? Exactly. I'll talk about that later. So I'm going to go over here first. Under the plus sign, you're going to create a part studio, as you can see. And then basically I'm going to select a face. So remember, because a Revolute mate is basically it takes a cross section of what you're using. I'm going to select a front face. And then first I'm going to sketch and I'm going to sketch a rectangle. So this time I'm not using a corner rectangle. I'm not using a center rectangle. I'm going to use a corner rectangle because I want it to hang onto one side of my sketch. So when I revolve it, my part is still centered. So you might be wondering, why do I want my part centered? Well, because when other people, especially in a big team, are reviewing your work, you don't want your parts scattered around because it's harder to find. And also the auto zoom automatically zooms in onto the center. So it gives your teammates a better user experience when they look or come review your design. So first, I'm going to draw this rectangle. So this is going to form the base of the pulley. But you'll notice over here that the pulley actually has a dip in here, right? So how we're going to create that is basically on that profile, we're going to add a dip. So if you come over here, it dips down and then it goes flat and then it dips up again. And then now we're going to talk about how to make your part accurate. So now if you can see, if I just try to draw a line, it'll tell you how long this line is. So if you see that text up here, this tells you how long the line you draw is. But it's really hard to get it like accurate. Like if I just wanted one, I'd have to try really hard. However, there's this tool called dimension. So over here, you can see this defines how long every line you have is. So if I come over here, I can define this to be, say, 6 centimeters, and this will automatically translate into 6 centimeters. If I want this to be, let's say, 0.5, then it'll become 0.5. And now you can see that this line is kind of outside. So if it's blue, like you see over here, you can simply freely move it with your hand, right? And then another thing is basically you can define the relationship between points and lines. So if you look over here, so first, if I want to define the angle of this, I can define it like this, right? And then I can enter the angles to be, let's say, 75 degrees. And then if I want to define this first, so let's just put this at 0.5. Okay, and then another thing you can do is basically you can define like the relationship between like one line and the other. So I can define this line to be parallel to this line. And then what you can do is you can define, I can draw a perpendicular bisector from here to here. So what I'm going to first do is I'm going to get the midpoint, right? And then once I get the midpoint, what I can do is I can define this line to be this line to be perpendicular to that line. So this just perpendicularly bisects my shape. And that ensures that I have a trapezoid. So if you look over here, I have perpendicular. And there you go. And then if I remove this define. Okay, and then now all I need to do is I need to make sure that this line is equal to this line. So what I'm going to do is I'm going to draw, or I'm just going to define this. As 0.125. And I can define this as 0.125. And then over here, I can define the distance between here and here to be negative 0.1. And then you can see that just creates a trapezoid like you saw it in there. Question? So this isn't real life. So this is basically a computer software. So if you think about how computers work, they kind of just are just plotting the points on a graph. So how they're finding your distance is just taking one of the coordinates and subtracting it from the other. So if you define it as a negative, it basically just ends up switching the coordinates. That makes sense. And then now all that's left to do is just define the depth of this ditch. And I'm going to put that as 0.25 as well. So you can see I have the ditch to my pulley. And now after we have this profile sketched out, I'm going to turn this 2D shape into a 3D shape. So we're going to use Revolute, as he said. I'm going to select the face that I just drew. And then for the axes, of course, is going to be the one on the center line. So if I go and select revolve axes, you can see it just creates a pulley, right? And now we're going to talk about how to make holes, right? So once again, first, I'm going to do a sketch. And I'm going to sketch out a rectangle. So what this rectangle is for, we're not trying to like cut a rectangular hole. This is just for defining like the positions of the holes, because many of the parts you're going to be buying come with hole patterns, and those hole patterns are usually defined in rectangular lattices. So it's easier to first define the rectangles and then draw the holes on them. So in the case of the part I'm using, it's defined in 16 millimeter squares. So this will be 1.6 and this will be 1.6. And now there are two ways to make holes. So the first way is by drawing circles on these and using extrude to cut them out. The second way is just using the hole tool as you see here. So this is relatively better because it helps you like adjust to whatever you're doing. So Onshape works as also an industrial tool. So they have a lot of industrial standards built into their design tool. So let's just say I want to select these 4 points as my holes. And if you can select a standard, and then you can select the size of what your screw is going to be. So in this case, we're actually going to be using M4 screws. So, and then you can see this is fit. So what does fit mean? So fit is basically how well a part or like two parts will mesh together. So there's normal, loose, and then there's close. So close is kind of like a press fit, so it's going to be really hard to put it together. And normal is just, it gives you a little tolerance. And then loose is basically your part can still wobble around in the hole that you made. So in this case, I'm going to go with normal. And you can see that it's defined as 0.45 rather than 0.4. So why is that? Is because while you're like manufacturing the part, you have like the machine isn't perfect, so it has little tolerances. And so you need to make the hole slightly bigger or slightly smaller depending on how your machine works. And that's going to help you basically create like adjust to your machine. And so you don't really have to do post-processing on the part you made. So I'm just going to question. So this actually comes with experience. So I remember when I first started printing, I did 0.45 and it was too loose. And now I think for all my 4 millimeter holes, I go around 0.42. So really after like the 1 or 2 prints, you'll start to get it like maybe it's basically like kind of like you're just gauging the range every time you print until you kind of refine it to a number that you're comfortable with. So now we're just gonna call this pulley as done. We're gonna move on to the assembly. So before we actually do the assembly, I'm going to talk about how to import parts. So as many of you are going to be entering FTC, I'm going to talk about how to get parts from the two main vendors from FTC. So the first one is going to be Servo City. And so you can just access it under servocity.com. So these parts are basically the parts that we like. So we use a lot of Servo City, and Servo City really sells two main companies for structure. So one of them is Imperial based company. So they design in a 0.77 inch grid pattern, or they design in an inch based pattern. And the one that we prefer designs in a metric 8 millimeter grid pattern. So that's very user friendly and it's very good for math because each grid is just 0.8 centimeters. So basically their page is pretty easy to navigate. You have structure, which is what you're going to be using the most. It's just all your channels. It's like the things that don't move. So it's the channels, things that hold your motor, and different types of plates. And then you also have motion. So motion is not only the gearbox, the motors and the gearboxes, but it's also the things that move, like pulleys, servo horns, and different gears, as well as lead screws. So in this case, the first part I'm going to import is a U channel, which is kind of like a plate that's kind of bent into a U shape. So I'm going to go under channels and go under low side U channel, and I'm going to select a 5-hole U channel. So when I click this file, it's going to lead me into the page and it's going to give you the technical drawings. So this is good to consider before you download the part. So like you can see how these parts are created. So if you're creating your own custom part to mesh up with that, you have a standard to use to create those parts. And then what we're going to do is we're going to click the step file. So this is just a link that downloads the step file to you. And so for this company specifically, it's going to give you a zip file. So what you're going to have to do is you're going to have to unzip the file into basically a folder of your choice. So I'm going to put it under demo. And then the next vendor I'm going to talk about is it's called Rev Robotics. So this company makes control hubs and they also make some other stuff. So they can be accessed under revrobotics.com. And so what I'm going to grab is one of their motors, which is the Cortex motor. And then, so for Rev, these step files come directly as step files. So if you scroll down, you can see there's the documentation just like the last vendor had. But over here, you have the step file, which you can click to download, and it just downloads as a step file. So I'm going to talk about how to import these parts as basically a step file. So I'm going to go back to the demo. And then, so in order to import, once again, you click the plus sign and you can see down here you have import. and then you have import. And then basically what you do is you select the step file. It has to be in like a native format that most softwares can read. So usually for these, you're gonna be getting the in step files. They might also be called STL/OBJ. There's like a different formats. You can just try importing them to see if they're compatible. But mainly from these vendors, you're getting step files. So here I'm going to import to this document. So I'm going to click import, and then you can see it's importing. So once it's done importing, it will actually show up down here. So I have already imported this, so it's under. Okay, that doesn't matter. Okay, so basically once you finish importing, it's going to show up inside your document, and you can access it under these tabs. An easier way to access them is actually under this. On the bottom left corner, you will see a tab manager. So if you click here, it basically allows you to search for whatever part you create. So as your files get larger, as you start assembling like robots in CAD, you're going to find this tool a lot more helpful as you have like hundreds of parts in each document and you need to find one quickly. So if I just search up RUV, you can see that it's already imported. So once it's finished translating, it will actually come in the form of in my part library. So now I'm going to talk about how assemblies work. So basically, what assemblies are basically how you combine part A with part B and like get them to stick together. So you first have to so basically Onshape works in the way that is they have mates that are defined based on mate features. So what mate features are basically the software identifies these key features on each part that you generate. And these key features will each come with their own XYZ axes. And so what each mate is so what mating is basically doing is you're taking one of these XYZ axes and you're lining it up with the XYZ axes of another part. And then you define where this part has freedom. So can it translate along maybe the x-axis? Can it maybe translate along the z-axis? Could it maybe rotate along the x-axis, so on and so forth. And you can also combine these, which is why there's lots of mates. So I'm going to insert a new document. So it's going to under create assembly. That's how you create an assembly. And I'm going to insert the pulley that we made. It's just called pulley. So here's a pulley. And then I'm going to insert let's say I want to insert this hub. Right, so basically what this so first I'm going to select a mate. So the most common one you're going to be using is fasten mate. So this one basically just locks the axes together and doesn't allow them any degrees of freedom. So this is very easy for me to use to demonstrate the concepts of a mate. So first, if I hover over this face, you can see there are 5 white dots over here. So as I hover over a white dot, you can see these little spikes pop up. So these spikes are actually the coordinate plane that I'm talking about. So each white dot presents the coordinate plane, and you can use that to define one of the mates. So if I select, let's say the central white dot, and then I can go over here, and now you can see there's even more white dots. Now, if you can see, if I move my cursor, this kind of shifts, and as I go to try to select a white dot, this plane shifts away, and it's very hard to click. So here's like what you do. So first you have to hold down the shift key. And then when you hold down the shift key, it kind of just freezes your white dots in place. So you can go ahead and you can select one of them. And now you can see this part is mated, although incorrectly, because these axes weren't aligned when the parts were created. So how we fix this is with the quick adjustment functions that Onshape provides. Namely, you can flip the part and you can rotate the part. So if I click flip, basically you can see it now flips into place. But say if this was a more complicated part, I could also rotate the axes by 90 degrees until it fits. So you can see the little hole that I've created is kind of shifting as I click this by 90-degree intervals. For finer adjustments, you can also click offset. So once again, you can see how the coordinate plane comes into play. So it tells you that the origin of one coordinate plane, how it relates to the other on the x-axis, the axis, and the axis. And you can change that right here to have them shift. So if you look over here, maybe I do like 1 and you can see it shifts down in the y direction. If I do like 10 over here, you can see it shifts away in the z direction. So now that we've created this, we're going to talk about different types of mates. So basically the first mate that you see is the fasten mate. So the fasten mate just gives you 0 degrees of freedom. The next mate you see is the revolute mate. So that's right here. So the revolute mate basically just allows you to rotate on the z-axis. This is very useful for simulating parts like bearings or like shafts, because shafts always go in a hole, and the hole, the axis must align with the shaft, the axis for it to rotate properly. And so if I insert, say, like a shaft into one of the holes, so let's say I just use this as a shaft. Let me delete this. So once again, I click the revolute mate this time, and you can see over here, it revolves. So now if I fix this part, what I can do is I can just turn this, like so. You can see, you can animate it and turn it. So what this is for is, first of all, you can just flex on your friends by having like your CAD robot move in the CAD software. But more importantly, this is going to allow you to move your part like on the actual robot, and you can turn like whole assemblies left and right compared to other assemblies. And you can check to see if there's interference between parts. And so this would be really useful before you like kind of 3D print something, to know that, is this part going to function correctly in the range of motion that I've defined it.
Like you rotate that pulley, this website would like simulate the other thing also turning.
So it depends on what's fixed. So if I fix the pulley, it would simulate the other whole thing rotating. If I fix the other thing, it would simulate the pulley turning. So one way to one way that we did this is in our states robot. So if you see our states robot, there's a turret up there. So we actually used many different revolute mates for each joint. So you can see right now I have the drive base fixed because there's nothing much to simulate on the drive base. And you can see as I turn, you can see that this, I have some parallel mates. Give me a sec. So as I turn this whole thing will turn. So you can see this joint turns. And then you'll also be only animating one joint at a time. And then do be aware that when you have like a whole like robot, every time it changes position, it has to re-render everything, which is why my computer is getting angry at me and the fan is buzzing, but also why, like, you can see this motion is not smooth. And so let's continue talking about the mates. So this next one is a slider mate. So a slider mate basically just gives you the freedom on the z-axis. So that kind of plays out when you're animating linear slides. And that can be seen on our world robot, which you can see here. We have 4 sets of linear slides, and Basically, like our states robot wasn't like it, like the concept was kind of not working as well as we thought because it was like very vision dependent, and that vision kind of is like kind of gets like slapped by the environment. And then so you can see the slider mate allows the slides to kind of move in a sliding fashion. Um, and then the other mates, basically what they do is they just combine these three basic mates. So planner mate is basically allowing translation on a plane. So I can slide the part around. Um, the pin slot mate is basically combining your slider mate and your Revolut mate. So it allows you to slide in and kind of turn, much like a pin inside a slot, which is why it's called the pin slot. Um, and then we have the ball mate, which is actually 2 degrees of rotational freedom. So you can turn one way, but also the other way. So it's kind of like a ball joint. So if you think about your elbow, that's like kind of how the ball mate works. And then the final one is parallel mate. So what this is useful for is when you have like large CAD files, you can define parallel mates to kind of freeze them in their respective positions. So you can just like keep it there and not have, so like maybe you're presenting to someone else and you want to just like keep it there so they don't like, you want to get to a certain position, but you don't want them to mess it up. So parallel mates are an easy way to kind of restrict the motion of your assembly. So basically how this all culminates is in our individual robots. So me personally, I've worked on 3 of these robots that we've created. And so you can see these parts that we make kind of just come together. So you can see, if you look over here, there's 3 tabs that we created, but under these are hundreds of different parts. So if I open up each tab, you can see like there's a bunch of different parts. And so what this will allow you to do is it will allow you to not only build a CAD representation of your robot to flex on the judges, but also to kind of check your design and basically see where things go wrong. So I'm going to give you an example of that. Yeah.
These parts here, how many were custom made and how many are imported from Canada?
So this robot was actually very custom made. So I think there's like 25 or like 30 of them. But a pro of using standard parts is basically they're tried and tested, and you can expect them to work. Like if you just put them there and you use them as the specification said. But like your own parts, you kind of have to kind of guess and check to see like, oh, is this strong enough? Is my 3D printing material or my like carbon fiber going to hold up?
In the season, things connecting these things together, it's standard parts versus building your own.
So actually doing the CAD takes around like maybe I've spent like 40 hours this season, like in total, like connecting different parts. But what's more important is calculating beforehand to like so you don't have to spend that much time on the CAD software. And so now I'm going to give you an example of how you can see whether things are conflicting inside your assembly. So I'm going to close out of most of these because so first view I'm going to teach you guys is the cross-section view. So what this does, it gives you a cutaway of your robot. So you can see like whether things are working as you expected. So this year, one of our regulations was basically that a guide for the pole could not exceed 4 inches. But our cup holder, since it goes inside the cone, the radius is bigger than is less than 4 inches. So we have to make sure that the cup holder is not exposed when looking down. So it makes sure that the pole doesn't contact. So to check that, what you do is you go under here. So right under the big box that you use to control your views is a drop-down tab. And you can see, quickly go through them. So these are different. So these are different views. So these are just predefined views. So these are like ways you can render your robot. But more important down here is you can see interference detection, which tells you if the parts you selected will interfere with each other. And the section view, which basically gives you a cutaway of your robot. So now I'm going to use the section view. So you can see it cuts away the robot on the plane that I select. And now I can easily see that this is actually an illegal part because this extends over the curve. And then another way that this can be used is basically to do interference detection. So if you have like a lot of moving parts inside your robot, what you can do is you can select like different parts of your robot. So let's say I just select these two parts. It will basically tell you if these parts are interfering, and it will highlight where it's interfering. So you can see where the teeth are meshing. And so by using that, you can kind of see small interferences that you can't see otherwise on a large scale. So to summarize, basically today what I've talked about is how to create your own part in Onshape, how to put the parts that you created and the standardized parts together, and also how to use the software to kind of check your design to make sure that it's working as intended. Thank you.
New instructs up. Is that a party aid kind of thing that comes from the standard for things?
Yeah, so the websites I showed you actually categorize how like each things work. So so there's also this website called Game Manual Zero that will kind of walk you through each concept, and it kind of gives you an implementation of those concepts in standard parts, and you can use that to kind of apply. And once you think you're ready for the step up, you can create your own custom parts that are based off of these concepts. And another thing is, if you want to learn more about the tools, there's of course a learning center in Onshape that helps you learn. Game Manual Zero. So I'll pull it up. It's the site. So if you Google Game Manual Zero, it should show up. Or if you go to gm0.org, it will also show up. Thank you.
Thank you.